Welcome, everybody. We're really excited to have you here for our third alumni panel. This topic for this week is on manufacturing. We have a fantastic lineup of panelists, Omar, Paisley, and Mitchell, who are joining us. What I think is from like an exciting wide range of companies as well. And so we're looking forward to y'all hearing from them and how they are involved in the manufacturing industry and their specific companies. I'm going to introduce our moderator for today, who's Professor Julie Rohrer. She's actually our most recent assistant professor hire in the department. We were very excited to have her join our department. She started in January, like this month, and she is, for many of our undergraduates, you might see her or have her in our senior design course, the ChemE 486 course. She has some really fantastic research, really exciting research that has a lot of industries in the state quite excited because one of her main focus areas, not all of what she does, but one of the main focus areas is on working on plastic upcycling. So we're really excited to see where her research program grows over the next few years as well. So Julie, I'm gonna hand it over to you to kick off our panel.
Great. Thank you so much, Professor Nance, for the kind introduction, and thanks to everyone for joining us. I am very excited to ask some questions of these three fine panelists. But before we begin with the questions, I'd like to give each of them an opportunity to introduce themselves, their name, current organization, and where they're living, hometown, and the year that you graduated from UW, as well as your current role and maybe a brief description of what it is that you do. Let's go ahead and start with Mitchell.
Okay, let's do it here. I have like this little corporate thing I pulled up, which I love. So pay no attention that it's maybe not full screen. We'll see. You guys see my screen I'm showing? Yeah. Okay. So I have a lot of the stuff answered up on here. So I work for PepsiCo, which owns Frito-Lay. I actually work in a Frito-Lay manufacturing plant. So you'll see I have a ton of roles in here. I can definitely talk about any of those that people are interested in learning more about. The one that I thought was the most fun sounding was telling people I was in charge of all potato chip production for the Pacific Northwest, which was true. It was a very snazzy title. It was actually one of my earlier roles, so I've since moved up in the company since then. But I graduated from UW in the ChemE department in 2017. And so I've been with PepsiCo about 6 years. They give me a little boost because I actually interned with them, so I can also talk about the internship there as well if folks are curious. I live in Vancouver, Washington currently. My current role, it's actually less acronyms. I like de-acronymed part of it. We love acronyms. I think the full thing, I wrote it down, is FLNA, PGT, BTT, UAT coordinator is what like my current title. So I can't tell anybody that ever. That doesn't make sense. But I currently work in basically a large like 1,000-person project doing some automation and like software updates. And the UAT stands for user acceptance training. So I'm like the air traffic controller of coordinating who's going to be testing what and when for that big change that's coming up. So kind of different from the manufacturing environment I spent the last 6 years in, but is very interesting. I think I covered all of the stuff that you wanted to, but if not, let me know.
Absolutely. Fantastic. Thank you so much. Let's go to Paisley.
I wasn't going to share it, but I do also have a slide about my life. I think it's probably something that our companies make us do. So I'm going to share it as well. Give it a second. Okay, so this also covers pretty much everything you guys asked for. So I was born in Honduras. I am a dual citizen, and I moved to Seattle for high school and college, obviously. I graduated from 2017, from the UW ChemE class of 2017. And I also worked at the nanofabrication facility at UW for 2 years while I was doing undergrad, which was really cool. I'd love to talk more about that later. And I've been working at Micron since I graduated, so about 5.5 years. I started as a shift process engineer in the dry etch process area. I did that for about 3 years, and then I moved to diffusion implant, but that's one of the acronyms on here, DIFI. It's diffusion and implant together. I was a shift lead engineer for about a year and a few months, a year and change. And then I've been a process owner in the DIFI area. What that means, so my title is process engineer, but I own certain processes that run in our diffusion furnaces. They're heat treatment processes, so anneals. We use inert nitrogen or sometimes some other gases like hydrogen to change the the surface materials on our manufacturing wafers. Some that we make semiconductors, memory chips. They're in almost everything. They're in iPhones, they're in Teslas, they're in so many different devices, and also data centers. Yeah, I love the Pacific Northwest. I have been there since I lived in Seattle since I was 14, and it's beautiful there. I got a picture here of a hike that I went on one time. I don't actually remember exactly where that is. And I love my dogs. Mitchell, your dog was really cute. Looked kind of similar to mine a little bit.
What's your dog's name?
The big one is Rocky, and the Chihuahua's name is Stella.
Nice.
Yeah. What's your dog's name?
Oh, it was Rhubarb.
Rhubarb. Nice. So yeah, I think that's about it. Was there anything I missed?
I think that's great. Thank you so much, Paisley, and great to see all of the dogs. Let's go to Omar.
Hello, everyone. I don't have a slide or a dog. I have a cat. So I moved to Seattle in 2014 to study college, and I attended the UW ChemE department. Graduated in 2019, and then I interned with SABIC in Indiana, where I am right now. I did an R&D internship, and then they took me on full time. And they put me through their 2-year rotational program. So it's a 2-year rotational program where we just hop between a few different departments. So I did reliability for 8 months, and then EHSS, which is environmental health and safety, for 6 months, and then process engineering for 6 months and operations engineering for 6 months. So it was pretty interesting to see kind of how a chemical engineer can contribute to those different departments. And eventually, at the start of last year, I rolled on to my full-time position, which is utilities process engineer, because we make all our utilities on site. So air, electricity, steam, hydrogen, nitrogen, everything. And also sustainability leader for the site. So I work with the corporate and global teams on sustainability initiatives. I think I got everything. I'm not sure if I missed anything.
Great. Thank you, Omar. Important question. Your cat's name?
Oh, Loz. It means almond in Arabic.
Oh, very cute. Love it. All right. So thank you so much for all of the introductions. We'll start for the questions with some set questions that we've prepared ahead of time. And then we will open it up to questions that the students are submitting through the Slido. So the first question is, what is your day-to-day like in your current role? And what tools, softwares, or programs do you use in that role? And as a follow-up, has this evolved since you started your job? So maybe we can start with Paisley or Omar.
Sure, I can go ahead. So being a process engineer, I've been a process engineer in some form or another, even though I've had 3 different positions at Micron. A lot of it is a desk job. So I'm sitting at a desk in a computer, using a computer most of the day. However, we're using, some of it is specialized software that's only available at Micron. We have in-house applications that were developed here. They're used for R&D, which is the department that I'm in. So we have statistical process control charts, where we monitor, our product measurements and our experiments. We have, software for looking up the history of our lots that run in our fab. We can also set up experiments, doing like design of experiments, DOE. And also we can document deviations using like quality reports. And we also have fault detection software. So I use all of these and probably more that I haven't listed. On a day-to-day. There is also a push for data science right now, and so we are using some programming software. Personally, I use a little bit of Python with Anaconda. Lately, I've been learning SQL, because there's a lot of in-house data mining that can be done, a lot of databases, and I've been getting pretty good at Tableau, if I say so myself. So we use that for data visualization, although other people in the company also use Power BI. I haven't learned that one yet. And I've even delved into Microsoft Power Automate. So those are just some of the different things we use for automation. And there's some Google Cloud, but I haven't learned that yet. And how my position or the software and How my job has changed since I started? Well, I started as a shift process engineer, meaning I was working 12-hour shifts supporting the fab, and I worked alongside, I still do, alongside equipment engineers and technicians. So I would go into the fab quite a bit, especially when I became a shift lead, I would go into the fab a lot. So that's a clean room environment. You have to gown up, put on like a whole, they call it a bunny suit sometimes. And it's like a very clean environment, no hair like spilling out, no makeup, that kind of thing. And now, now that I'm a process owner, I don't go into the fab as much, but I do go in when the tools that my processes run on are undergoing maintenance or repairs, because that gives me a better understanding of how the equipment works. There's a lot of collaboration, like I said, with equipment engineers and technicians.
Great. Thank you so much. Omar, would you like to share your day-to-day and et cetera?
Yeah, so kind of similar. It's a lot of desk work, but the nice thing is I can get out pretty much whenever I feel like it. So there's a lot of well, I begin my day by checking up on the process, looking up the process parameters, making sure there aren't any abnormalities or anything, and then I usually meet with the operations engineer and the operators themselves to discuss any like hiccups or any problems they've been having, any abnormalities, and it's a lot of more long-term strategic kind of fixes for the plant, so increasing efficiency and whatnot. So in terms of any programs we use, it's not super sophisticated. We use a lot of SQL, Visual Basic. Actually, I was surprised when I started and I saw Visual Basic. But for more, I guess, strategic and long-term efforts, we try to use Jump or JMP. It's kind of like a data analysis tool that we use to sometimes build models or create our forecasts with.
Great, thank you. Mitchell.
Yeah, so mine's a little different. I definitely only recently kind of got into more of a desk job. For the first 4 or 5 years of my career, working in supply chain and like a manufacturing plant on the floor, I was actually just managing people. So I had teams under me, so I'd manage those teams, and so I was using Excel a lot. And so I feel like recently I've gotten pretty good at Excel. I'm sure there are people that are much better at Excel than I am, even still, but I love Excel. Power BI is something I really want to learn. We use SQL data. I've learned how to like integrate SQL data into Excel. I use ALM, which is like application life management, which is a testing software, just very recently. But mostly what I've learned how to do in there is to take data from that, put it in Excel so I can make it look nice and do business analytics with Excel data. So I'm a big fan of Excel. There, I know there are Excel classes at UW that honestly gave a good foundation for it for when I came in. And a lot of because we have so many different manufacturing plants in America and North America, a lot of times very similar documents are very different from plant to plant, even though they achieve the same thing. And so sometimes you'll get a template for like calculating how many potatoes you're going to use, and it's all in Comic Sans and it doesn't work, and there's circular references, and I'm just like, what are we doing? This is like a Fortune 50 company. So I came in and I had the great benefit of like, well, I just had Fetner teach me about Excel, I think, at the time, and go, I can make this look nicer. And so kind of started to get to do some of that stuff. So a lot of my day-to-day was basically working with people, and my projects, a lot of times I utilized Excel as a program, as a software program. So, yeah.
Excellent. Thanks so much. Excel, definitely a powerful tool. All right. So the next question is, does automation play a role in the work that you do? And do you see automation growing in the manufacturing areas of your industry?
Absolutely, and almost every capacity of our plant has. So I'll kind of highlight on like 2 pieces of automation that I think are really fascinating, that kind of blew my mind when I first started and going into the manufacturing environment. So amidst like the thousands of like conveyor belts and things moving around, one of the things is this piece of equipment called the optics, and it's basically an automated sorting machine. So we want to send you guys the best possible quality chips. How do we manage our quality of chips? Well, I calibrate this big, like multi-million-dollar piece of equipment, this big fancy camera with a set of pictures of chips, the right color that I want. I don't want brown spots. I don't want caramelization. I don't want burnt holes, you know, nothing weird. You guys are getting perfect chips, right? And basically we send thousands and thousands of chips. I mean, the minimum amount we do is 3,000 pounds an hour out of a single line that we have at the plant. And so just thousands and thousands of individual chips fly through this machine every second, and it scans all of them as it goes through. And it basically makes them go over like a Hot Wheels ski jump. And it looks for bad chips, and it has a little air cylinders. It has like 126 different air nozzles that blow the bad chips that it sees on its camera out as it makes a jump. So they're making a jump. If it's a good chip, it successfully makes a jump. If it's a bad chip, a little air valve opens up and pushes the chip down to a different conveyor belt. But sometimes that creates a lot of waste. So that belt actually goes on a so it goes to recirculate it. It goes back into the same machine on a different side, and it checks it again, just in case. It scans all those same chips a second time. And then if it's still bad, it blows them out to a different conveyor belt. And then that goes to waste. So it's about like making sure that quality is correct and that we're not putting too much waste. Like we don't want to use all this oil. We don't want to use that heat and electricity and throw away a bunch of product that we could be selling or that we could be getting out to people, right? So that was one that was like very fascinating to me when I first started. Other ones more recently that have come into like packaging automation, we still have people there packing. We still have people running bag makers, as we call them. We recently did an upgrade to a lot of those bag makers that basically added cylinder chambers to kind of the bag makers, where they essentially shake the chips, or they help position and align the chips dropping down a chute, very like as they drop down a chute, so that we can seal the bags more easily, so that we're not getting like chips stuck in the seal and then you get like stale chips or things aren't good in quality. So again, trying to reduce and eliminate some of that waste. And those are, one is very old. The optics has been there for tens of years. And the bag maker one is last year. So, I mean, it's just continuing. When I first started, we had people talking about how we used to have about 10, they literally will say, we used to have like 10 grandmothers employed that would sit there and cut potatoes in half to get them to the right size. And now we have like a little conveyor belt that like walks them up and they automatically slice themselves in half. And it's kind of crazy. But so it's definitely very prevalent and also just gonna, I think, keep continuing, especially for at least our manufacturing environment is definitely planned for more.
Wow, thank you so much. That's really fascinating.
Super cool stuff.
Would any of the other panelists like to add anything about automation?
I think Mitchell spoke pretty well to it. I'm not super involved with automation just because we have an automation team on site, but I mean, some of the other benefits are, you know, we use AI to prevent you know, big sustainability or greenhouse gas releases, basically. So we have a huge cogen facility that puts out, you know, a million pounds of steam and 75 megawatts of electricity, and that thing is burning up a lot of natural gas. So when we're running it in a less efficient way or something, we have automated controls, and AI kind of controls the optimization of that facility to pretty much reduce greenhouse gas emissions. In the case where, you know, it's trending towards a high release, it shuts it down basically, and we have to take a site shutdown. So the implications of that are pretty significant on our end, and you know, just in general, some other I guess benefits of automation is, you know, safety issues. You know, it reduces operator interaction with the process, so you're putting your people at less risk. You're reducing process upsets and deviations. So, but Mitchell pretty much got all of it.
Great, thank you. Do you have anything to add, Paisley, or?
Sure. Yeah, I could throw something in there. Very fascinating how Mitchell and Omar talked about different ways that we can use automation. I was thinking about this question in terms of efficiency and cutting out like redundant steps or, you know, things that don't make sense. We're always trying to use automation to make our jobs easier, work more efficiently. I mean, Micron makes different kind of chips than PepsiCo. We make memory chips. So when you keep talking about chips, Mitchell, I'm like, have to remember that you're talking about the edible ones. But yeah, the semiconductors and memory chips, it's a very competitive industry. You know, we've got a lot of big companies that we're always trying to perform each other and, sell the best chip for the cheapest price. Yeah, I see the emoji name, Elizabeth.
This sounds like exactly the same corporate speech we get. We're trying to make the best chips. We got a lot of competitors.
Yeah, exactly.
We got to keep.
We're speaking the same language, but we're saying different things. So anyway, we actually have this program or methodology called TPM, Total Productive Maintenance, and it's all about like making things, documenting things better and making them more efficient. And so part of that is we have something called power walks, where we try to take something that we do commonly, often, and we basically break it down step by step and look for ways to reduce the number of steps or replace certain steps with other steps that are faster. Where can we leverage automation or data science, or even just moving something so that it's closer to where you need it? Like literally one of the power walks one of my equipment engineers did was we needed to have they do leak checks, and they have these hydrogen drop things. Sorry, the words are failing me right now. Basically, that you could either use a bottle that you carry around, a gas bottle, or you could have it installed so that it's right next to the tool. And so he would put in a work order to have it installed in a different area, in a bay that he wasn't able to use that. The point is just easy things like that. They're not necessarily data science, but they are still automation or reducing inefficiencies. So.
Great. Thank you all so much. Glad to see that automation is helping us make our chips of all varieties and helping our processes. The next question pertains to how chemical engineering informs your work now, and whether there was a single ChemE class, either a core class or elective, that strongly relates to what you do. And as kind of a follow-up question to that, one of the questions in the chat was related to how manufacturing usually implies the incorporation of industrial systems engineering, and how that might have played a role in the current work that you do. Would anyone like to start? Maybe a favorite class in ChemE that was relevant to the work that you do now?
I can start. I think maybe Paisley and Omar might have more like relevant experience to talk about specifically, like ChemE influenced my work. I really don't do strictly chemical engineering. I've taken a lot of the principles of that and I've gotten to apply it, and it served me a great benefit. But I do not do process engineering at this point, right? So I think for sure a class, there's a lot of classes that I think very much helped me. I've already referenced some of them. There's also a lot of classes I wish I had taken, like there's some optimization ones and other things like that that I know were available that I did not take that I think would have been great. But I'm doing okay. So I'll talk about the one that I think got me the job at the company from the internship. And that was a class called Creativity and Innovation. I really enjoyed that class. It was phenomenal. They talk a lot about trying to take some time out of your day and think about like the bigger scope problems, or try to come up with an idea, right? Like sit down and go, if I could solve this at my company, this would be huge. Like, what could I do? And work towards that. Because you've got people that will go in and they'll do your day-to-day every day. And, that's fine. That's great. But if you can like solve that major problem, you have now just, really added a lot of value to your company. And so that was something I did. So I actually went into my internship and I really liked that. I've been doing the idea log. I don't necessarily keep up on it as much as I used to, but I used to do it like every day. And I'd go in and I pitched all sorts of crazy ideas. Honestly, it's amazing to let me work there at all. Based off some of the ideas I came up with, I ran the full gambit during my internship between, hey, let's get rid of all of these magnets that catch any metal that we don't want in product, and just put now with 30% more iron on the bag, and then it's marketed as a health food. Obviously, that was not serious. I was joking, but I did actually suggest it to my boss at one point as a joke, and they still hired me. So it's great. Have fun with it. But I did get to like pitch because of one of the like Excel classes I'd done, and knowing some of the like optimization stuff that I knew just from in ChemE at the time. I actually pitched an idea on how I thought I could make ordering potatoes more efficient and a lot less waste, and we'd have a better, what we call load to fry time. So when we grab potatoes from the farm to when we fry them, has a lot to do with our ability to convert to like not waste the potatoes. Potatoes start to basically disintegrate the second you pull them out of the earth. So there's a lot of stuff that goes into that. We won't go down that road. But I pitched a way that we could improve the efficiency of our ordering, basically making a model for doing it in Excel. And they liked it so much they replaced what I was actually working on as an intern at the time and had me work on that instead. And it ended up saving the company like $2,000 a week. So I very much paid my internship off. I think it gave me kind of a brand professionally and as somebody that was like an idea person. And I largely contribute kind of doing that process and going in with those fresh ideas and that fresh look on the outlook and just like pitching and being fearless and trying to learn a lot about that stuff as a reason why they ended up bringing me back. So definitely, even if you don't take that class, I think taking that time out of each day to like think about ideas or ways you could solve a big problem and just kind of putting a little effort in towards that, I think is always just a really good practice to have.
Oh, thank you. That's fascinating.
I can go next. I think earlier in my career, when I was applying for internships, what really impressed them was the polymers lab. For us, it was in spring quarter. I don't know if it's still the same way. And Professor DeForest, I believe, is the one that taught us that. So my ability to speak to that class and you know, show my knowledge in plastics, because I was trying to get into the plastics industry, really impressed them. So that really helped get me my my internship. And once I started, because I started as a R&D intern, my supervisor pretty much would give me just on the side kind of things to learn. And I was like, you know, I already know all this stuff from that class. So it really teaches you a lot about polymers and characterization and all that kind of stuff. So that's what helped me kind of get my foot in the door. But I would say on a day-to-day, mass and energy balances helps a lot. Every single unit in our site, because we have like I think we have 9 plants on our site, so each one makes something different, and each one of those plants needs a mass and energy balance that needs to be updated and maintained. And for me, another great class was mass transfer. That was actually with Professor Nance. So thank you for that. Those are I'd say the main two that I use on maybe not a day, maybe a week-to-week basis.
Great, thank you.
So I had a little bit of trouble coming up with a single class, just because I think the entire ChemE curriculum kind of develops you to think in a certain way about like systems and specifically like, I'm going to give some examples from my work. So I've worked in dry etch and diffusion area, and I'm a process owner in diffusion. So the processes that I work on run in furnaces, which are basically these big tubes that heat up, get really hot. You flow gas through them. You'll pump down to a certain pressure, so you're working in some type of vacuum usually. And all of these parameters, these are things you can control. You can set the temperature, you can set the pressure, you can set the gases and how much gas flow you need. And so these furnaces are closed systems. And so I don't do a mass and energy balance on the system, but I do think about all of the components of it and all the species and everything that's going on. And these parameters that I said you can set or control, sometimes we call them tuning knobs because there's a certain range. Like maybe you can do something at 600 degrees Celsius that you can also do at 650 or 700. And when you're designing experiments, which we do in R&D a lot, you can do a skew where you're testing different conditions, different temperatures, different pressures, different gas flows, things like that, or gas mixtures. Something cool about temperature is I recently started working with PID controllers, and so that brought me back to my ChemE curriculum. I can't remember the name of the lab, sorry. But I'm sure Elizabeth will throw it in the chat. But yeah, PID controllers are fascinating because you're trying to hit a certain set point in temperature, and the furnace tube is long. It's, you know, several feet long. I don't know exactly. It's like maybe 5 feet tall. And so you've got different heaters spread out throughout the furnace. So you call them zones. So you've got your top of the furnace, top center, center, bottom center, and bottom. So we have 5 different furnace zones, and you've got TCs that are measuring the temperature, and then you're feeding back that reading. And so if you're ramping up or cooling down to a certain set point, you don't want to overshoot it. You don't want to ramp up to 700 degrees, but then go like 750, because that's not good for quality control, you know, in your products and your experiments. And so a lot of what I do is fine tuning, you know, making sure the set points are working correctly, and also maybe fiddling with PID controllers to And that's been really fascinating. I had to like dig deep to go back to my my ChemE classes because I recently started doing this. And I couldn't remember anything about PID controllers, but it's all coming back to me now.
Great, thank you. As a new professor, it's validating to hear that the courses we make you suffer through end up being relevant to your future careers. And so the next question we have is, why did the chemical engineering degree or program appeal to you as a major? And was working in manufacturing something that was on your radar or something you were interested in before starting the major, or did you learn about it as you were taking your classes?
So I kind of tell this story as a joke most of the time, but I got into engineering mostly because as a little kid, like really little kid, I really liked math and science. I loved playing with Legos, and my parents and all of their friends were like, "Oh, you like math and science? You like Legos? You should be an engineer." And I didn't get that they were joking. So then I became an engineer, which is mostly true. I got into chemical engineering because it's kind of like a Swiss Army knife of degrees is kind of how I think about it. It lets you apply a lot of different things into a lot of different fields all over the map, way more than I knew even when I was looking into it. I originally really was actually interested in getting into petroleum engineering. Chemical engineers can do what petroleum engineers do. I was from Alaska originally, and big up in Alaska, obviously, is petroleum engineering. So I was like, I can get back to Alaska where I grew up, partway through my career, I kind of lost interest in that. A variety of things were changing, not only just, my views on that as a whole, but also just where the industry stood at the time I was in college was a huge like hiring freeze and then layoff. So they weren't really hiring folks for a long period of time. And I got really into the food and drink science industry, specifically around the brewing and distilling. So I actually started I don't know if it's still going on, but I started a ChemE brewing and distilling club at UW, which is really cool. We did like a variety of tours. We brewed our own beer and cider and stuff oh yeah, it's still going. All right, that's so cool. We did our own like beer and cider for our graduation, which was really cool. I felt that was really fun. Came out great. We visited Puget Sound Round. I'll give them a shout out as some alumni in Woodinville that are ChemE alumni from UW that ran a successful like distillery on the side. And I'm like, future goals, I want to do that. I want to run a distillery as my hobby. Yeah, that sounds great. So got really into that, kind of was looking at stuff my junior year for internships and saw PepsiCo was hiring, didn't know PepsiCo owned half the world, including Frito-Lay, and, kind of went in there against all the advice where they say, look up your company, go to the one you want the most last or whatever. So I went to PepsiCo first because I didn't know anything about it, but they have pipes, they're making liquids. That seems like something a process engineer would probably be able to help with. Basically, my whole rationale, I'll test out my pitch on them. My pitch was apparently really good. Got an interview, pitched Portage Bay Cafe to them as hey, you should go check out that restaurant. I'm sure they enjoyed the food, and then gave me a call back and got the internship. And I kind of, walked you guys through how I think I got the job from the internship. So it's kind of unlikely. Ended up in the career I'm at right now because I really enjoyed the people I worked with during the internship, really enjoyed what I found I was doing. So when I got into supply chain and saw the projects and saw some of what I got to do with it, just really loved those kind of unique challenges and that like coordination, the mix of both, like desk work and like thinking and like project management, as well as getting to work with people. I'm I'm pretty extroverted. I like to talk. I like to, build rapport with the team. So getting like a team, getting to manage people, and then getting to work on projects kind of seemed like a really good fit for me. And so ultimately, when they offered me a job at the end, took it. So it was not really, it was very unlikely the way I got there from where I started, but really glad that that's kind of how the path went. I was just very open to it.
Great, thank you.
Yeah.
I just want to give a special shout out to Mitchell's cider because I was also class of 2017, so we graduated together and it was really good.
Habanero.
I can also touch on this question maybe a little bit. I didn't really know what I wanted to do. I'm actually a non-traditional student. I did freshman year at a different college in California. I was homesick. I went back to Seattle. I actually went to community college. I went to Seattle Central for a little bit, like a little over a year, and then I transferred to UW. And so it was while I was at Seattle Central, I kind of honed in on what I wanted to study. And I can't really say exactly why I wanted to study ChemE. I think I had an idea that I wanted to be an engineer because I wanted to like save the world through clean energy, which I still want to do. I'm gonna pivot at some point and go into like solar. That's kind of my dream one day. But right now, memory chips are also very important, and I love making them. And I also like really liked chemistry in high school, and I was like, I'll just keep taking chemistry classes in college. Turns out chemistry gets really hard but it's still worth doing if you love it. I struggled with organic. I don't know. That's kind of not my forte, but yeah, so I thought I would go into solar. I thought maybe I would work for like some startup. I never thought I'd be like at a big company with, thousands of employees worldwide. What really got me into the semiconductors and manufacturing, though, was when I was at UW. I started working at the Washington Nanofabrication Facility. I started there the summer right after sophomore year when I got admitted to UW ChemE program. And so I worked there for 2 years as a research assistant, but not just doing research I was both a research assistant in that I would learn like the operations of a clean room, specifically like how to keep it clean. A clean room is very clean, as you can imagine. And so I was part of the crew people that like would clean everything up, and I would like walk around with a particle monitor, testing how many particles were in the air, which was really cool. But then also I got hands-on training on all of the various processes that are used in semiconductor manufacturing. So I did hands-on like photolithography, dry etching. I actually presented a poster at the UW Research Symposium on dry etching, basically like using it to form through silicon vias and troubleshooting some issues that we were having. Deposition, wet etching, wet stripping, metrology. That was actually really cool because I got to use a scanning electron microscope myself. I got to learn how to use it, which was really fascinating because it's really powerful. You can zoom in crazy, like see nanometers and angstroms scale features like on the surfaces of the wafers. So yeah, big plug for Washington Nanofab facility, WNF. I think they hire in the summer. Every summer they hire research assistants. So if you're interested, it's over in Fluke Hall down by the Burt Gilman Trail. Really fascinating work there. So just working at WNF for 2 years, I got recruited through the UW Career Fair. I forget which one it was. It was the one in the spring. Micron recruiters who were UW alumni came, and I had this experience under my belt, and I really liked talking to the guys that came from Micron. And then they flew me out because they were still doing in-person interviews back then. So they flew me out to Boise, and I just fell in love with the city. It's got beautiful like rolling foothills right next to the city, and there's a river that goes through, and it's kind of a desert climate, but it's also still in the Pacific Northwest. So I love that. So yeah, I didn't know that I was going to semiconductors or manufacturing, but just learning about ChemE and learning about semiconductors got me there.
Thank you. Omar, you want to add anything to add?
Yeah, I mean, I would say it. I came to Seattle 2014, and I attended North Seattle Community College. So I was a transfer student to UW. While I was at North Seattle, my roommate at the time was actually a ChemE major at UW, and he would tell me all about the major and the classes he's taking and the projects he's working on. So it really appealed to me at the time. I wasn't great at sciences. I failed chemistry in high school. I didn't do so great on my first college exams, but it really appealed to me. So long story short, I got into UW somehow, and while I was there, I enjoyed all my courses, and I really wanted to go to a field where I can apply as much as I learned basically to my job and working in manufacturing. And I think in the size of the facility that I work at, and the type of work that we do, the sheer number of people that are on site, we have experts from every field. You're working with everyone from finance to people that never graduated school, and everything in between. I work with mechanical engineers on a day-to-day basis, electrical engineers. It's a very diverse field, and no day is similar to the previous. So I think that's what appealed to me in the manufacturing world. You have the freedom pretty much to choose your own route. And even within our company, I don't know how it is at other companies, but the 2-year program where I jumped around the different departments and kind of got to choose what I wanted to do at the end, that also appealed a lot to me, because I got to experience, we graduate college, we don't always know what we want to do at first. And so being an ops engineer for 6 months, and then a process engineer, then a environmental engineer, and then a reliability/maintenance engineer, that was a great experience for me.
You mind if I chime in? I was just going to say, Omar, very, very similar, not necessarily in the same kind of style of rotation, although PepsiCo does something like that where we're like supposed to change our roles every year to year and a half. This tends to be the frequency at which we swap around. But definitely just to reiterate on the manufacturing environment, every day is very different. For us, I kind of have I know the same base. I want to make chips, just like Paisley, want to make chips each day. But whatever weird thing comes up, what supply chain shortage issue I'm dealing with, how I'm approaching that, a lot of that changes every day. So it was very engaging from something that you don't want to just be stuck doing the same thing over and over again. Had a lot of variety and a lot of spice and interest that was able to kind of keep the same basic goal. Very interesting. The full 6 years I've been working with the company.
All right, excellent. Thank you, everyone. So we've talked a little bit about some of the internships that you've had and some of the software that you use that have helped give you training for your current job. Are there other specific tools or processes that you use, and were these things that you learned through coursework or extracurriculars or internships, or things that you had to learn on the job for your current role?
So I touched on my experience at the nanofabrication facility. I just want to say that Micron will hire people that don't have any nanofabrication experience either. So there's a lot of on-the-job training. There's a lot of coursework that gets assigned to you when you start out. I started out as a shift process engineer, and you get a 30, 60, 90 plan, basically goals for your first 30, 60, and 90 days. You start working on small projects and things like that. But really, the first 6 months are actually just learning, shadowing other people and learning and slowly starting to do things on your own. We do a lot of troubleshooting, and so a lot of it is learning what types of questions to ask, essentially. And a lot of it is we use the 5 whys technique to get to root causes of issues. So a lot of times the question is, why did this happen, and why did that happen, and then why did that happen? But then other things just other types of questions as well. So a lot of it is on-the-job training. There's lots of classes. We have an internal curriculum, Micron courses you can take. We also do external, through Coursera and things like that. You can get credit through doing those. We have Micron sponsored Coursera licenses, essentially, and other websites and things like that. So WNF, nanofabrication facility, was really helpful, but it's not a requirement. I didn't do an internship. Working at WNF was my internship, essentially.
Great, thank you. Does anyone else have anything they'd like to add to that question?
Omar keeps unmuting, and then he saw me unmute, and then he remuted himself. So Omar, you should just go. I'll go last. That's fine. You should go.
No, I was just gonna say, most of the training is done on the job. Honestly, it really depends on the industry you get into, and the training that you're gonna get is going to be specific to that industry, right? So, whatever department you're working with will provide you with the needed training. They're not just gonna, leave you stranded, basically, or they'll assign you a mentor or something like that. And that's something that we had both mentors, and also every quarter we had at least one training that lasted a week. So they do provide a lot of training, and it just depends on what field you're in and what industry you're in. Go ahead, Mitch.
Absolutely. I very much agree with that. Honestly, it is very much the kind of training has actually changed a variety of times as we're trying to nail it down. I had a weird experience when I first started, because I had interned. They had a role that they needed to fill, and I had worked at the plant, and I didn't actually get onboarding or training. They just had me go right into role, which was super crazy and fine. I ended up being totally okay. And I just kind of was able to give myself and kind of sought out some training. Nobody else that started at the same time I did had that same experience, and nobody since has, so I wouldn't worry too much about it. Definitely just to kind of reiterate, the companies want you to succeed and will give you a lot of tools and training and things to let you do that. I've been like Lean Six Sigma trained, and you could do that in college, and it's honestly probably a nice feather in your cap to learn about some of those like optimization and like lean principles for manufacturing. That's something you're interested in, but by no means, like a lot of times we do that as an internship. You'll go get white belt trained. It's like a great practice. We've done flipped internships where we've gone to high school students and been like, here's your, like, we're not qualified to give you a certificate, but here's what the principles of Lean Six Sigma are, that kind of stuff. So I would say not really like a tool, program, or process, but something I would really think is very advantageous and has served me very well is get a lot of leadership experience in a variety of ways you can. That could be, you know, like I tell people, that can be leading your group project in your ChemE courses, you know, and scheduling and coordinating that stuff and just taking a little bit, one more step of ownership of that process. Could be doing a club, could be starting a club, could be being, you know, an officer position in AICI and Wiki, you know, any of those things, right? But that has been invaluable at like every level of and every role I've had. Having that like leadership experience is like my fallback. I'm very confident that I can learn things and learn things quickly, and also work with teams, which will help me drive success. So I think a lot of my successes come from being able to work with other people, and both individually, but also just on that team and help lead that team.
Great. Thank you so much for the thoughtful responses. Was there something you wanted to add, Omar, to that?
Yeah, I would add one more thing is, you know, also keep an open mind to you know, who you're learning from and all that kind of stuff, because when you're in the manufacturing industry, you know, the engineers are great. They'll give you all the technical advice that you need, and the trainings are great. But also spending time with the senior operators. Those guys have been, you know, at the plant for 15, 20, 25 years. And those guys have a ton of knowledge on how the actual process works, and, you know, all the knobs to turn and everything. So, you know, keep an open mind to listening to them, getting their opinions. Believe it or not, they are the subject matter experts, and they do have a good opinion when it comes to stuff, and they do have a lot of knowledge to share.
I want to chime in on what Omar just said. 100% to that too. Like, so I started at the company, and you know, at like 22 years of age, right? And I was technically in charge of people that were 50, you know, older than my parents. All the way down to like 18-year-olds, you know, just a huge diversity. So again, being able to like listen to those folks that have been there for 50 years and, you know, gain their buy-in, gain their knowledge, and let them help you, rather than try to like, you know, run roughshed or, you know, some of that stuff, again, kind of comes back to a certain amount of, you know, with that leadership. But the people out on like the floor that have been doing this for a long time have a lot of experience. And just because, you know, I wouldn't necessarily take, oh, we've always done it this way as a good reason for something to remain in existence. There's also tends to be a lot of history and things that you can learn from those as well. And so I think, you know, valuing that opinion really goes a long way, kind of in any endeavor you're doing.
All right. Well, that takes us to 9:20. I want to thank the panelists so much for sharing. I think I certainly learned a lot, and hopefully all of you have taken some notes and gotten some great ideas about what you can do to think about a manufacturing career. With that, I think we'll close out unless there's anything else you'd like to announce, Professor Nance.
Thank you all to the panelists. If we can do a round of applause, those on Zoom with your emojis and our in-person, I'm not sure how the mics are picking up, but we really thank y'all for your time.